Welcome back to a new video. As you know, interstellar research has always led us to new discoveries and has allowed us to understand, step by step, what surrounds us beyond our atmosphere. This has been possible thanks to our technological means and the ingenuity of scholars belonging to the scientific community. Among these achievements, it has been possible to estimate the number of stars present in the universe. Clearly, this refers to the observable universe. This number has been calculated using mathematical models, and it seems that in this portion of space which we can afford to look at, there are as many as 300 trillion stars, at least according to a study from 2010. Years and years of observation and increasingly detailed studies of the cosmos have opened many paths that have led to the formation of a ranking of the largest stars in the universe and consequently to a basic model for classifying them according to their relevance. In this video, we will explore what this basic model is. We will also ask ourselves if there are actually any limits, at least regarding the growth of a star, but most importantly, we will explore some of the most well-known stars to conclude with the one currently considered the largest star in the universe. If you're ready to follow me, we can begin. But first, if you haven't done so yet, subscribe to the channel to support this project and remember to activate the bell so you don't miss future publications. Now, let's start our interstellar journey. When we talk about the largest stars in the universe, we must first make a distinction between the mass and the volume of these celestial bodies. The mass, in fact, corresponds to the internal matter of the star, while the volume is simply the space that it occupies. One thing that should be underlined is that, in reality, massive stars are not very often taken into consideration, and this is because, normally, they contain less mass than it might seem, at least from the outside. In fact, as stars grow, they begin to lose mass. Moreover, this is what seems to be happening to the Sun. To give a brief overview, with the loss of mass and with the depletion of nuclear fuel, the Sun will evolve from its current state to a future red giant, in totally apocalyptic and decidedly future terms. When its time comes, the Sun will be so large that it will swallow Venus and Mars, and it is not entirely excluded that it could reach even Earth. Currently, the star classified as the most massive based on its mass is BAT 9098, a star 226 times the mass of the Sun. Currently, it is not clear how this star reached such an important mass, but it has been hypothesized that this star became so by merging with another not far from it. In addition, this star seems to be very young compared to many others. In fact, some mathematical models have detected that it may have an estimated age of 7.5 million years. This youth is particularly notable according to the scientific community, especially when compared with the age of our Sun, which is about 4.6 billion years old. BAT 9098, moreover, loses mass at a surprising rate. Since it was born, it has already lost the equivalent of 20 suns in terms of mass. Given its activity, it is predicted that its existence will end dramatically, probably through an evolution into a supernova, which will give birth to a black hole. However, despite its notable mass, BAT 9098 is not the largest star in terms of physical dimensions, at least in the ranking drawn up to date. In fact, due to its radius, which is estimated at 37.5 times that of the Sun, it is far from reaching the top positions in this ranking. According to research, the largest star in the universe until some time ago was Scuti, and it was considered the largest, at least in terms of physical dimensions. This red giant, as we said, was once considered the largest in physical dimensions and was estimated to be 1,700 times the size of the Sun. But through calculations carried out with more recent mathematical models, these estimates have been reduced. It seems therefore that its dimensions are, compared to what was calculated previously, only 775 times those of the Sun. Clearly, this downgrade has significantly moved the star down in the ranking of the largest stars. Another candidate for the title of the largest star was Stevenson 218, a possible red supergiant truly huge. It was estimated through a theoretical model that if placed in our solar system, Stevenson 218 would have been able to engulf even the orbit of Saturn. Also through experiments, it was calculated that a journey around this star at the speed of light would take almost 9 hours. And this is definitely a relevant fact if we think that the same journey around the Sun would take only 14.5 minutes. Stevenson 218 stands out equally as one of the most intriguing and mysterious stars. Initially, it was estimated to be 2,050 times the radius of the Sun, and referring to what was said previously, there are scientific limits placed on the evolutionary growth of stars. In this case, Stevenson 218 challenges all of them. The theories that there is a theoretical limit to the size a star can achieve set 1,500 times the radius of the Sun as the ultimate limit not to be surpassed. However, as anticipated, Stevenson 218 seems to be in every way beyond this limit, leading us to question the correctness of the estimate and raising doubts about what was previously thought to be known. So, how much can a star grow? The dimensions of Stevenson 218 could have been overestimated. This is especially possible due to the uncertainty a priori, given its distance from Earth. With this awareness, we know that it could vary even up to 50%. This scenario is reminiscent of the case of Scuti, the star we mentioned before, whose estimate of dimensions was significantly reduced after a better calibration of its distance. So what do we base on then to understand what the correct dimensions are? Well, surely the difficulty in determining the exact dimensions of a star depends not only on the mass, but on much more. It is necessary to know its composition. It also depends on the evolutionary history and the strength of the stellar wind. For Stevenson 218, the outer atmosphere can theoretically continue to expand almost without limits. But at a certain point, the diffused gas of its outer layers would merge with the interstellar medium, making it difficult to define where the star ends and where space instead begins. Measuring the size of a giant star is therefore a challenging task. These celestial bodies, thousands or millions of times more voluminous than the Sun, are located at huge distances, emit intense luminosity and have constantly changing atmospheres, often enveloped in massive clouds of dust. These factors make it difficult to discover their true size. Despite these challenges, astronomers use a series of factors, such as the distance from Earth and the surrounding environment of the star, to obtain more or less accurate estimates. But then, what is the largest star in the known universe? According to current rankings, this title is currently held by WOHG 64, a red giant located about 160,000 light-years away in the Large Magellanic Cloud satellite galaxy. Its enormous size challenges our current understanding of the universe, leaving us to reflect on the vastness and complexity of the space that surrounds us. The star WOHG 64, located in the Large Magellanic Cloud, emerges as one of the most astonishing red giants in the cosmos. With a radius estimated at 1,540 times that of the Sun, this star, if placed at the center of our solar system, would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. This measure aligns perfectly with the theoretical limit of star growth and matches the dimensions of many other red giants and supergiants discovered. WOHG-64 is likely in the final stages of its stellar evolution. These stars, having exhausted their nuclear fuel, undergo an expansion of their outer layers, transforming into true cosmic giants. The star is enveloped in a torus-shaped dust cloud, about a light-year wide, composed of material it has expelled. Incredibly, it is estimated that the material in this cloud would be enough to recreate our entire solar system 9 times. But is WOHG-64 really the largest star in the known universe? Probably not. Other research has provided different estimates for this colossus. One source, for example, measured WOHG-64 as 2575 times the radius of the Sun, even surpassing the dimensions, albeit possibly overestimated, of Stevenson 218. If this measurement were correct, WOHG-64 would engulf the orbit of Saturn, and a journey around it, at the speed of light, would take almost 10.5 hours. In comparison, light takes only 4 hours to reach Pluto from the Sun. Although it is clear that the universe hosts stars of enormous sizes and in different evolutionary phases, until we have more accurate measurements, it will not be possible to determine which is the absolute largest star. However, with ongoing advances in observational techniques and technology, astronomers will be able to refine their measurements and better understand these cosmic giants. WOHG-64 might indeed be the largest star ever observed in the known universe, a fascinating giant that reminds us how small we are in the face of the immensity of space. Certainly, we look to the future knowing that the ranking of the largest stars in the known universe may vary. But currently, there is no scientific answer regarding how much a star can evolve, and consequently, it questions the limits set so far. We have reached the end of this video. Today, we explored a very interesting topic. If you liked the video, leave a like and write in the comments if you found the topic interesting.